let's look at this reaction and determine what is oxidized and what is reduced. In order to do that, we need to assign oxidation numbers to everything. This carbon has an oxidation number of 0 because it's in an elemental form. The same goes for this oxygen. Oxygen is -2 when it's in a compound, but when it's in an elemental form, the rule about 0 takes precedent. So it's 0 there. On this CO2, we know oxygen is -2. That's one of our rules. Oxygen contributes a -4. We know it must be neutral overall. So this carbon must be a +4. Okay, and then to see what is oxidized and what is reduced, the way I remember it is that whichever substance has an oxidation number that is reduced, in this case oxygen, that is what's being reduced in the reaction. So oxidation number reduced. The opposite is true. The one whose oxidation number increases is oxidized. So that's carbon. Okay, now let's talk about it in terms of agents. When we say oxidizing agent, we're saying which reactant is oxidizing the other one. So in this case, it is oxygen. Because it is doing the oxidizing of carbon. It's oxidizing carbon. So it kind of works out backwards that you have the oxidizing agent is the one that is being reduced. The reducing agent is the one that is being oxidized. Another thing I wanted to talk about is the oxidation states of carbon. When you get to organic chemistry, almost everything is covalent. And you use these oxidation numbers to assign states to carbon and some other elements to keep track of what's happening in the chemical reactions. So let's just start with this CO2 that we already did. We said this is -2 and we figured out this carbon must be +4 as we did above. This hydrogen, our rule for hydrogen is +1, and that makes this carbon -4. So this is kind of the range of states for carbon. This one is the most reduced. And this one is the oxidized form. When you get to organic chemistry, you don't always figure out all these numbers. You can just look at the compound and say the more oxygen it's bonded to, the more oxidized the state. The more hydrogen it's bonded to, the less oxidized and the more reduced the state. And so you'll have compounds like this. Something like this, and we would say this compound is not as reduced as this one, but it is not as oxidized as this one. This one kind of falls in between.